Hi, this is Mrs. Lloyd with Lesson 8-1, Logarithms and Logarithmic Functions from McGraw-Hill for Algebra 2. We have a few vocabulary for this lesson. Logarithm, the inverse of an exponential function used to deal with very small or very large values. And logarithmic function, a function of the form f of x is equal to log with base b of x, where b is greater than 0 and b is not equal to 1. Pause the video and record these vocabulary. Our lesson goal: write logarithmic expressions in exponential form and write exponential expressions in logarithmic form. And I just wanted you to see that a logarithmic function is the inverse of an exponential function. So you can see the red line is 2 to the x. Sorry. Or an exponential function. And then log base 2 of x is the blue line. The logarithmic function, they are inverses of each other and they are reflected across y equals x. So we are first going to look at converting from logarithmic to exponential form. So these are in logarithmic forms. You see the word log. To convert to exponential, quite easy if you can remember, and I would draw these arrows. 4 to the third. That 4 is called the base of the log, and it's going to become the base of our exponent. Equals 64. That's the exponential form. And 4 to the third is 64, so that is true. Again, 3 to the negative fifth is equal to 1 over 243. And 3 to the fifth is 243, so 3 to the negative fifth is 1 over 243. Nine to the 1/2 is equal to 3. If you remember, a 1/2 as an exponent is the same thing as a square root, and the square root of 9 is equal to 3. Why don't you try this one? The log of base 125 of 5 is equal to 1/3. One 25 raised to the 1/3 is equal to 5. And again, 1/3 is the same thing as a cube root. Cube root of 125 is 5. Now let's go the opposite way. We're going to start with exponential form and convert to logarithmic form. And as you can see, we start with exponents, so we know we're going to log form. And it's basically the same sort of thing. Draw these arrows. Log base 7 of 117,649 is equal to 6. Again, base of a logarithm is the same thing as the base of the exponent. Same thing again. Log base 8, and this is a subscript below the log. 1 over 512 is equal to -3. Try the next one. And I think I have one more for you to try. Yes, try this one. Now we're going to evaluate logarithmic expressions. And if you have the right kind of calculator, you can do this on a calculator. But we don't really need a calculator to do this. So when I see log base 216 of 6, this is how I'm going to solve it. I'm going to let it equal a variable. Let's just say y. And then I'm going to do the same thing we just did. 216 raised to the y is equal to 6. So then I have to think, what number, 216 raised to what number would give me 6? Well, since I know it has to equal a number smaller than 216, it's going to be a fraction. And I recognize that 216 is a perfect cube. So I know, and you can check it in a calculator, that 216 raised to the 1/3 will equal 6. And you can check that in a calculator. So let's try it again. The log of base 512, 8 equals y. So I'm looking for 512 raised to some power that will give me 8. I know it's got to be a fraction again because I'm going to 8, I'm starting at 512. Well, I know that 8 to the 3rd power is 512. So since I need a fraction, I know that this one is once again 1/3 because the cube root of 512 is 8. Why don't you try these two? On the first one, 9 raised to what power would give me 1? Well, I know that anything raised to the 0 power is 1. And the second one might stumble you a bit because if you notice, there's no base down here. And when there is no base, it is called a base 10, a common logarithm, which we'll have a lesson on that. But if there is not a number given for a base, that means the base is 10. So 10 to what power will give me 10,000? 10 to the 4th power will give me 10,000. And for an exit ticket today, a multi-step problem. I believe we just did this part because we have to start with the innermost parentheses. So log base 10 of 10,000 we know is 4 because we just did it above. So then I need to do log base 2, 4. So 2 to what power gives me 4? That would be 2. And then I need to do log base 16 equals 2. So I'm thinking 16 to what power gives me 2. Well, I know that 2 to the 4th is 16. But I see that I need a fraction, so I know that the final answer is not 4, but 1/4. Should probably write that here. And there's the answer. Thanks for watching.